Hey guys, I'm back again. So right now we did determinants of a 2 by 2 and determinants of a 3 by 3. So these are determinants. Why do we need to do those? To find our next topic, which is called the inverse matrix. So these inverse matrices, meaning take a matrix and find its inverse. So let me start with a 2 by 2 inverse matrix. All right, so that's today's lesson, is a 2 by 2 inverse. All right, so pretend that we do have a matrix, A, B, C, D, which is a 2 by 2. First, we have to check if the determinant, we first have to check the determinant, the determinant cannot be 0. Not if, but it cannot be 0. If the determinant is 0, then the matrix does not have an inverse. So first what we are going to do is we're going to check AD minus BC. If that's equal to 0, no inverse. Can't do it. But if it equals anything other than 0, then there's an inverse. Okay? So how do I find inverse? All right, so let's take this ABCD again. Here's my matrix. I want to find its inverse. Its inverse is defined by 1 over its determinant. Let me say DTA. Let me call this matrix A. 1 over the determinant. And then we're going to rewrite this 2 by 2 in this fashion. First, do you see this? This diagonal A times D? This is called the main diagonal. We are going to flip them. So now this becomes D and A. Do you see this C and B right here? We're going to keep them. We're not flipping. We're going to keep them, but we are going to make them opposite signs. So this is minus C minus B. So the inverse of a 2 by 2 is first we have to find a determinant. Well, this is in the first step. If it's equal to 0, we're not continuing. But if it's not equal to 0, then it's 1 over the determinant, whatever that is. And then you're going to switch the main diagonal and then put minus signs on the other diagonal. And then ultimately, this is a number. These are numbers. We're going to multiply this number by each one of those. All right. So for instance, find the inverse of -9, -9, -2, -2. First, I got to check if it does have an inverse. So I'm going to check the determinant. -9 times -2 is 18, minus -9 times -2 is 18. So this particular one does not have an inverse. So this is no inverse. Can't be done. Okay. So let's check this one out. Let's do 0, -2, -1, and -9. Okay. So let's find its inverse first. 0 times -9 is 0, minus -2 times 1. -1 is a +2. So I have it's determined to be -2. Okay. So if this was A inverse is 1 over the determinant of A times this flip. So 1 over its determinant was -2. Flip the main diagonal. So we had 0 and -9. If I flip it, now that becomes -9 and 0. And I'm going to change the signs of the other diagonal. If their negatives becomes positive, their positive becomes negative. So this is a -1 and a -2. So if I change their signs, they're going to become +1 and +2. So this is what the inverse is going to look like. And now I just got to multiply this 1/2 by each one of those. So my answer is -1/2 times a -9 is a +9/2. Negative 1/2 times 2 is a negative 1. Negative 1/2 times 1 is a negative 1/2. Negative 1/2 times 0 is 0. A inverse. So the inverse of this matrix, again, this is a step-by-step. You can see that you can start from here and say, oh, okay, I see this is 0 minus so that's going to be 0 minus 2. That's a negative 2, so it's 1 over negative 2. Flip your diagonal, take the opposite signs of this, and then just do your multiplication. Okay, so let's see if we can do one more. And this time, let's maybe make it a little bit faster. Right here. Let me call it B now. Let's do 2, negative 10, negative 11, and 18. Oops, sorry, just 8. Just 8, no 18. All right. So B inverse is 1 over, as you see, this is 16 minus this 110. 16 minus 110 is negative 94. Do you see that? I'll do it again. Remember, this is an 8. 2 times 8 is 16. If you can't do it on the side. Minus 10 times 11 is 110. 16 minus 10 is negative 94. Let's flip our main diagonal. So this is 8, 2. Take the opposite of those, 11 and 10. So I end up with negative 8 94ths, negative 10 94ths, negative 11 94ths, and negative 2 94ths. One thing that we have to do is if it's reducible, then please reduce. These are even numbers, can be reduced, can be reduced, can be reduced. This one can't. So technically, I get negative 4 over 47, negative 5 over 47, negative 11 94, and negative 1 47th. Okay? So technically, I should be writing B inverse B, not B to the negative 1. This is inverse of B. And that's all there is to inverse of a 2 by 2. Okay? So first, check the determinant, because if you don't do that, it might not be possible. I mean, I knew here that's going to be some number. So that's why I just did it right here. You can do a quick check right there. And then flip the main diagonal, take the opposites of the other diagonal, and just multiply. And if you can reduce, reduce. No decimals. Everything is in fraction format. No decimals. Okay? So that's all there is to this inverse matrix of a 2 by 2. Next time, we'll do an inverse matrix of a 3 by 3. All right. See you guys. I'll send the homework pretty soon.